Spirometry is a way to test lung function. So this man is breathing into and out of what's called a spirometer. So spirometry is a breathing test that evaluates lung or pulmonary function, and it measures various volumes and flow rates of air. Respiratory cycle, just like the cardiac cycle was from the beginning of one heartbeat to the beginning of the next heartbeat, a respiratory cycle is the beginning of one inspiration to the beginning of the next inspiration. We have respiratory volumes and respiratory capacities. These are the amount of air that moves in and out of our lungs during various phases of breathing. So we're going to explore these in significant detail. So first, let's look at respiratory volumes. Respiratory volumes can be measured with a spirometer. You saw a spirometer at the beginning, but this is another type of spirometer, and we'll use yet a different kind in class. Then we'll look at respiratory capacities. Respiratory capacities are determined by combining two or more respiratory volumes. So before we look specifically at respiratory volumes and respiratory capacities, let's look at this graph here. So this is time, and on the y-axis we have lung volume measured in milliliters. So as you're watching this video, you're breathing in and out slowly at a controlled rate. That's called your tidal volume. So as you breathe in, the volume in your lungs goes up. As you exhale, the volume in your lung goes down. So this is called your tidal volume, and this is about 500 milliliters. So think about like a 2-liter bottle, about a quarter of that is what you're breathing in and out. And that's called tidal volume. Now, as you're breathing in and out, if at the end of your exhale cycle, you then exhaled all that you could, that would be the expiratory reserve volume. Similarly, think as you're breathing in and out, when you get to the end of that inhale, then you continue to inhale all you can. That's called your inspiratory reserve volume. What I want you to notice is when you breathe in, the line on the graph goes up. And when you exhale, the line in the graph goes down. So there's another volume here. This is called the residual volume. This is the air that's in your lungs that you can't blow out of your lungs. It's sort of fixed in there, if you will. Of course, it's not the same volume each time because that gets exchanged every time you breathe, but the amount of the residual volume stays constant. And that's something we need anyway, because we do need that pressure inside our lungs to keep our alveoli open and not collapsed. So those are 4 volumes that we're going to look at now. We have tidal volume. That's the volume of air that enters or leaves the lungs during one respiratory cycle. And the average is 500 milliliters. I put that in orange because that's a volume that you'll probably want to know, because you'll need it for the test and for the lab. And then inspiratory reserve volume, that's the volume of air that can be inhaled in addition to the tidal volume. So during forced inspiration, the inspiratory reserve volume is about 300 milliliters. So just so we're clear on that, when you're breathing normally, that's tidal volume. And at the end of your inspiration, if you continued to breathe in as much as you could, that would be inspiratory reserve volume. So that is sort of beyond the tidal volume. And then we have sort of just the opposite. We have the expiratory reserve volume. That's the volume of air that can be exhaled during a maximally forced expiration. And that's, again, beyond the tidal volume. And the average of that is about 1,200 milliliters. So when you're breathing in and out, just casually, at the end of your exhalation, if you continued to blow out all the air you could, that would be your expiratory reserve volume. And then we mentioned the residual volume. That's the volume of air in your lungs that just stays in there even after you've expired all the air that you can. And that's about 1,200 milliliters. Now let's look at the capacities. Remember that the capacities, those are determined by adding the volumes together. We're not going to look at all of them. Let's just focus on 2. Let's look at the vital capacity. So the vital capacity is the sum of your tidal volume plus your expiratory reserve volume plus your inspiratory reserve volume. So see that? Tidal volume plus expiratory reserve volume plus inspiratory reserve volume. So all three of those together make the vital capacity. If you wanted to measure your vital capacity, what you can do is you could take the largest breath that you can and then exhale all of it. When you do that, that would be your vital capacity. And then let's also look at the total lung capacity. The total lung capacity includes the vital capacity in addition to the residual volume that's left in your lungs. That's a good number to know because it's about 6 liters, your total lung capacity. So here's the respiratory capacities. We have the inspiratory capacity, the functional residual capacity. We didn't really look at either one of those, but there's definitions there if you'd like to read them. And the vital capacity. The vital capacity is the maximum volume of air that can be exhaled after a maximal inspiration. So that's your tidal volume plus your inspiratory reserve volume plus your expiratory reserve volume. And that's about 4,600 milliliters or 4.6 liters. And then your total lung capacity, that's the total volume of air that your lungs can hold. Remember, we got that by adding the vital capacity to the residual volume. And that's a little bit under 6 liters. And like this says, it varies with age, gender, body size, in addition to what type of shape you're in or medications that you're on. There's one more thing called the anatomical dead space. It's sort of interesting, but that's a volume of air that remains in the bronchial tree that's not involved with gas exchange. So we mentioned this before, like when you breathe in cold air on a really cold day, or even if you're in a sauna and it's extremely hot, when you breathe in, you don't damage your lung tissues for several reasons. One of which is your lung capacity is about 6 liters. But if you remember, your tidal volume is only 500 milliliters. So you're only exchanging, what is that, 1/12 of your total capacity at any given time, about 1/12 of it. Also, when you breathe in that 500 milliliters from your tidal volume, not all of that 500 milliliters actually makes it to your alveoli. Some of that just remains in your trachea and in the bronchial tree, and that's what the anatomical dead space is. And then the fraction that does make it to your alveoli, that's been warmed up while it travels through the bronchial tree anyway. So for those 3 reasons right there, that's why you don't damage your lungs when you breathe in hot air or cold air. So in conclusion, we looked at 4 volumes. We looked at tidal volume. That's the air that you're breathing in and out right now. It's about 500 milliliters. We looked at expiratory reserve. That's how much you're able to exhale after you've already exhaled what you normally would because of your tidal volume. And then after you've inhaled what you normally do during tidal breathing, if you were to breathe in as much as you could, that would be inspiratory reserve. And then the last volume is residual volume. That's what remains in your lungs, regardless of what you do. And then we looked at 2 capacities. We looked at vital capacity. Remember, you can get that by taking in the biggest breath you can and then blowing everything out completely. That gives you the vital capacity. And then lastly, total lung capacity. That's everything. Vital capacity plus residual volume. And that's about 6 liters.